Welcome back, class. So now that you've had a chance to watch that introductory video, we are going to look at, in this session, we're going to look at a couple of the topics that were discussed in there, notably the idea of molarity and dilution. So let's first get started by, again, just defining what we mean by solution and some other vocabulary terms. So a solution is, again, another term for what we learned as a homogeneous mixture. So when we work with solutions, visually it often appears that we're working with one material. Now, we divide a solution into two parts. We have what's referred to as the solvent, and this is the majority component of the solution. So this is what we have the most of in our solution. And we have the solute. These are the minority components of our solution. So typically, right, when we say we're dissolving something into something, right, the thing that we're dissolving is our solute, and what we're dissolving it into is our solvent. Now, again, in this course, when we talk about solutions, we are almost always talking about what we call an aqueous solution or a water-based solution. And this is simply a solution where water is our solvent. Now, when we talk about solutions, we have to be able to talk about how much solute is in a given amount of solvent. We need to be able to quantify. And this is called expressing the concentration. Now, of course, we can express the concentration in a relatively qualitative way by talking about things like we have a dilute solution or we have a concentrated solution, right? These give some sort of general idea of, oh, we have very little solute in a dilute solution, or we have a large amount of solute in a concentrated solution. But that's only so useful, and ultimately we need to have ways to quantify this. Well, there are numerous ways to express the concentration of a solution. For this point in the course, we're going to focus on the most important to chemistry, and that is what we talk about as molarity, abbreviated by capital M. And not surprisingly, this is a mole-based unit. Right? And we've learned about in the last few chapters about how moles are central to the way we quantify matter, and so it's also going to be central to the way that we quantify matter in solution. Right? Now, specifically, molarity quantifies it as moles of solute per liter of solution. Now, it seems obvious, but it's easy to make the mistake. We want to make sure that we understand that it is liters of solution, not solvent. Right? So it's not the amount of solvent that we have in there, it's the amount of solution that we're creating, right? The combination of the solute and the solvent. So, in equation form, we often will express this as molarity equals moles over liters of solution. So we think about molarity as moles per liter, right? That's the ultimate units when we think about the molarity of something. Okay, so now that we've touched on the basic ideas, let's look a little bit more in detail and do some calculations with molarity. So what if we're interested in preparing a solution of a known molarity, right? How would we go about doing that? So if we look at the picture, we can get sort of a basic graphical overview. Let's say we wanted to prepare 1 liter of a 1 molar solution. the idea that I have a 1 molar solution means that in my solution I have 1 mole, and we're going to be sodium chloride, per every 1 liter of solution. That's what the designation of a 1 molar is, 1 mole per liter. So if I want to do this, I'm going to dissolve up or measure out 1 mole of sodium chloride. So this would be the molar mass, right? So we're going to have 58.44 grams or 1 mole of sodium chloride. And I'm going to add water, right? This is my solvent, so I'm going to add solvent. Now, the key here, and this is the important, is I'm going to add water until the 1 liter mark is reached. Now, notice I did not say add 1 liter of water, because if I were to add 1 liter of water, the volume would rise too high because we have some volume being occupied by the sodium chloride now. And so, while it may be very close to 1 liter of water that we're going to add, we don't just add an amount of solvent, right? Because this is not per 1 liter of solvent. We add enough solvent until we obtain, in this case, our target volume, 1 liter of solution. And the result is 1 liter of a 1 molar solution. Okay, so now let's go back and look at some problems working with molarity. And just I'll write up here to remind you that molarity is moles solute liter solution. Okay, so how many grams of sodium chloride are needed to make 250 milliliters of a 2.0 molar solution? So if we think about what we're given, we're told what the molarity of our solution is, and we're told the volume of that solution that we have, and we're asked to find how much sodium chloride is in there. Now, ultimately, we want to know grams of sodium chloride. But using the molarity, right, we can't get to grams of sodium chloride, but we can get to moles of sodium chloride. So we know here that, if I were to write this out, 2.0 molar, right, equals moles of sodium chloride, right, we don't know that, over some volume. Now, I don't have a volume in liters, right? So it's important to understand that we need this volume in liters, right? So we need liters of solution here. Now, I do know the volume, but I know it in milliliters. So before I can start this problem, I have to convert my volume into liters. So let's go right up here and we'll do that. So we have 250 milliliters. If we remember our metric conversions, right? Excuse me. 1 milliliter is equivalent to 1 times 10 to the minus third liters, right? Milli is times 10 to the minus third. So, watching my dimensional analysis, we find liters, milliliters cancel. So I'm going to end up with 0.250 liters here. So now I know what my liters of solution are. 0.250. So I have 2 molar equals some moles of sodium chloride per 0.25 liters. So I need to solve for how many moles of sodium chloride this would be. Well, if we do a little math here, we can see that 2.0 molar times 0.25 liters equals some number of moles of sodium chloride. Now, sometimes it's a little tricky to see the units here, but always remember that anytime we have molarity here, right, what we're really saying is molarity equals moles over liters. So the liters are going to cancel out, right? So by multiplying the liters, I'm going to cancel out the liters here, and we're going to be left with moles, right? So if you get confused, you can always, instead of writing molarity, if you want to, you could write that as moles over liters, and then I could be able to cancel out liters and liters, and I would be left with moles. So, to do the math here, I end up with 0. Do the math, I end up with 0.50, two significant figures because of my molarity, moles of sodium chloride. Now, ultimately, this is not what we wanted, right? The problem called for grams. So once we have moles here, then it's just a matter of taking those moles and converting them into grams. So we need grams of sodium chloride per mole. And so molar mass, 58.44 grams of sodium chloride per mole. So doing that, I end up with 29.2 grams of sodium chloride. So, if I wanted to make 250 milliliters of a 2 molar solution, I would need to utilize 29.2 grams of sodium chloride. And then, of course, I would weigh this out, and I would add enough water so that I had 250 milliliters of solution. Okay, let's try one more, a little bit different. In this problem, it says, what is the molarity of a solution containing 100 grams of sodium chloride in 2.5 liters of solution? So here our target is the molarity. We're told the amount of solute in grams, and we're told the volume of solution. So our target here is, right, molarity equals moles of sodium chloride over 2.50 liters of solution. So my target here is my molarity, but I don't know the moles yet, but I do know the grams. So let's just start off here by converting my 100.0 grams of sodium chloride into moles. So as we've been doing, we're going to do that by dividing by the molar mass. So 1 mole of sodium chloride is equivalent to 58.44 grams of sodium chloride. So that gives me a 1.711 moles of sodium chloride. Now I use 4 significant figures here because of what I have, my 100.0 grams, right? So now I know my moles, and I can go back and calculate my molarity, right? So molarity is going to equal 1.711 moles of sodium chloride over 2.50 liters of solution, and that's going to equal 0.684 molar. Notice the 3 significant figures because of the volume. And so the concentration of this solution would be 0.684 molar. Alright, so now here's a couple examples. Now we're going to be using molarity quite often when we talk about solutions, so let's do one more practice problem. And I want to focus on something that I just did there a couple times, but maybe didn't, point it out directly. And that is that molarity is often used as a conversion factor between moles of solute and liters of solution. So if I know one of these two things, along with the molarity, I can figure out the other one. Now, if we want to think about how this works, let's think about, again, general equation, molarity equals moles per liter. So that means if I want to calculate the liters of solution, if I do my algebra, is going to be moles of solute times the molarity. So in other words, I multiply by molarity to get my volume of solution. On the other hand, moles of solute is going to equal my molarity times my volume. So it's going to be my volume of solution times my molarity. And I forgot to write something up here, so let me go back and just make sure this was clear. If I want to get the liters of solution, right, it's going to be the moles of solute divided by the molarity. And so if we want to find the liters, we're going to take the moles divided by the molarity, or we're going to divide by the molarity. If we want to find the moles, we're going to take the volume and multiply by the molarity. And if we look quickly back here, that's what we did right up here, right? Our target was moles right here. And so to get the moles, we took the volume multiplied by the molarity. So a lot of problems will involve this kind of using the molarity as a conversion factor. It's how we go between volume of solution and moles of solute, which is going to become really important when we move into a next section where we want to utilize volumes of solution when we do stoichiometry problems, right? So we ultimately need to take a volume of solution and figure out how many moles of the solute, right, the actual chemical that's reacting, is in there. But let's focus on this problem first. So we want to know how many liters of the 1.5 molar, in this case sodium hydroxide solution, contain 0.5 moles of sodium hydroxide. So let's see what we know. So we know the molarity, right? 1.50 molar. And we know the moles of sodium hydroxide, so we know the moles of solute. And we don't know the liters of solution. Well, if we want to find the liters of solution, right, if we think about the algebra, if I'm going to multiply, bring liters over here, have liters times molarity, but then to get liters by itself, I have to divide by molarity, so I end up with liters of solution equals 0.50 moles NaOH divided by 1.50 molarity. And if I do that math, we end up with 0.333 liters of solution. Again, three significant figures because of the numbers, the three significant figures here and here. Okay. So, molarity. Now, the last topic in this little section is going to talk about another topic that was mentioned in the video, and that is this idea of diluting a solution. So taking a solution of some known concentration and lowering it by adding more solvent. So this is the idea of dilution. And as was mentioned in there, we have a pretty straightforward equation that we can do it. And it's illustrated right here, right? This M1V1 equals M2V2. Right? And as we see here, we're starting out with 0.15 liters of a 10 molar solution, right? That's our what's sometimes called a stock solution, our one solution, if you will. Right? And we're going to try to target a 3-liter solution. So that we can make a 0.5 molar solution. So we need to add enough water to bring this up to 3 liters. Now, in this case, right, I knew what the initial molarity and volume was that I was going to use, and I know what I was targeting, 3 liters of 0.5. But what we can demonstrate here is what M1V1 equals M2V2 really talks about is that the moles of solute don't change. So if we think about our dilution equation, right? Remember, molarity times volume, or liters of solution, equals moles of solute. And since in a dilution, all we're doing is adding more volume, we're adding more solute, we're not changing solvent at all, the amount or the moles of solute that are dissolved in there are the same. So if we know the moles at the beginning, we know the moles of the same are going to be end, which allows us to utilize this equation. So the key here is moles in the beginning equals moles at the end. And so that's why we can use this molarity times volume at the beginning equals molarity times volume at the end. So now let's do a couple examples. To what volume should I dilute 1 liter of a 3.5 molar stock solution of sodium chloride to get a 1.5 molar solution? So if I want to think about what I know, well, I know my M1 equals 3.5 molar. And I know my V1 equals 1.0 liters. And I know my M2 equals 1.5 molar. My V2, right, this is what I'm trying to get. Right? That's the volume that we're trying to calculate. So M1 V1 equals M2 V2. So I'm going to have 3.50 molar times 1.0 liters equals 1.5 molar times V2. So now we just need to solve for the volume. So I get 3.5 molar times 1.0 liters divided by 1.5 molar equals 2.3 liters, right? This is my V2. So if I check my dimensional analysis, right, my molarity cancel out, so it makes sense that I get liters. I have two significant figures here because if I look at my numbers, the smallest number of significant figures is 2. Now, how would I actually make up this solution in lab? Well, the key is, right, dilution. You're adding more solvent. So in other words, you're adding more water. So if I take my initial volume of solution, I had my 1.0 liters of solution, and ultimately I need to end up with 2.3 liters of solution. And to do that, I'm going to add X liters of water. Right? I'm going to add some water to do that. Well, so since 1 and this have to add up to 2.3, right, I just need to take my X liters here, so my X liters of water, right, is going to equal 2.3 liters minus 1.0 liters equals 1.3 liters of water. Okay. So to make this solution, I'm going to take my initial 1 liter of my stock solution, I'm going to add 1.3 liters of water to get to my ultimately 2.3 liters of solution. So dilution. A very useful tool, something that is utilized a lot in lab, and so something we should understand how to calculate using our dilution equation. So this wraps up what I want to talk about in this session. Next time we will talk about, again, how to utilize these solutions in stoichiometry and what we learned about in the last couple of chapters. And then we'll go on to talk about different types of solutions in terms of what was called in the video electrolytes.